Hey, welcome to the FreeBSD channel. So as a part of FreeBSD Networking Sub-system, in my previous episode I have discussed about a quick introduction, and also I have done a quick code walk. And soon after I released the same, I got once in a while various emails, especially these are viewers who are onto Linux kernel and system software development. They are very eager to learn FreeBSD and also eager to work on FreeBSD, especially the reason that FreeBSD is much tightly integrated, something unlike something like Linux kernel's architecture, because you have the kernel's user space component of Linux and the kernel space component of Linux as such, and everything comes together as a part of distribution rather than something like FreeBSD, because the entire FreeBSD comes as a part of single operating system. There is no logic like a distribution where kernel is different and the user space components are different in the case of FreeBSD. So I was actively discussing with the same about the same to the viewers, and they are also asking me to do some kind of a comparison between the FreeBSD stack, network stack versus the typical the popular Linux kernel networking subsystem components. So what I did is I have done a quick Google drawing. As you can see here, this is my Google drawing. I just did over here, and then I just exported the same, so that once this video is edited, what I can do is I can just add this video here, and also I can add some of the references, and also that it gives a sort of flow. In case if you are newly watching this series, you can first watch the first episode, and then followed by which you can watch this episode, and then you can also go through this picture which I have exported as a part of reference to understand the various modules or the source code components of FreeBSD and something like Linux kernel source. So that's what it is. So you can see here what I did is I have split into a couple of parts. One is the interface. Any networking subsystem have some of these components which are important. Of course, I have not yet added a socket subsystem over here. Sometime down the lane I may extend the same picture over here, and then I may export a refined version of this diagram, so that it includes also other components. So one can imagine, if you see a networking subsystem, you have components like interface or the network ports. You have to manage these ports, and you need to couple these ports to the packet data structure. So in the case of Linux, it is skbuf data structure. In the case of FreeBSD, it is mbuf data structure, as you can see here, which is something the same which I have discussed in the intro as well as. So you have these components. So I have classified as three main components. One is the interface and port management. The second one is the packet management. The third one is the typical V4 and V6, ipv4 and ipv6 stack. So you can see here these three things I have plotted down. As I said before, I may do for socket as well, so that it will also cover where exactly you can find a match in the case of Linux kernel, where you find in the case of FreeBSD, where you can find its respective source. It is not going to be like a 1:1 match. Please understand, FreeBSD is an entire different operating system versus something like Linux. It is just Linux have borrowed the Unix architecture. As we understand, Linux is a sort of a Unix clone, so that it mimics something like Unix, but it is more it has evolved over several decades, and it is more beyond than Unix at this point of time. So this is what it is, whereas FreeBSD is more sticking towards the typical Unix experience. So you get that traditional Unix approach with FreeBSD. Also, it is lightweight, it works much faster, it is even ideally suited for building any network appliances and stuff like that, versus something like Linux platform, because Linux is more suited for building large scale server farms and other use cases which we generally see in day-to-day world. So that's what it is. Whereas FreeBSD is very interesting. It is really interesting to build tiny embedded devices which doesn't need an elaborate operating system. It is also ideally suited for say in the case of pfSense, you can make a very lightweight firewall, and rather than firewall, because it has a primitive firewalling feature, but rather than firewall I should say a lightweight but yet powerful network forwarding router or something like that. So these are various cases with FreeBSD. You can't find dedicated Linux distributions for specific task, although you can find it in DistroWatch. I'm not denying that, but still you can't find something like what you get it in the FreeBSD world. You get FreeNAS. It is a dedicated distribution of FreeBSD meant for quickly deploying a NAS system. I don't find anything like that so much mature in the world of Linux platform. Same thing if you see a pfSense routing platform, I don't see anything quickly 1:1 match in Linux world, which is also popular. I'm not denying that you can find few distributions in distro world, or you can pull the Red Hat Enterprise Linux or else CentOS and you can build your own stuff. The question is not about building your own stuff. The question is, if he's a network admin or somebody like that, you need to have a professional ready to use distribution which is containing or which is comprising all these components. So that's what it is. So in this way, if you compare FreeBSD and Linux, you don't find much in Linux world, but you get very good Linux server platforms, and you don't I don't yet found much in the sort of FreeBSD world, although I should not comment much about, because I'm still new in the FreeBSD operating system as a whole as such. So anyway, so let's get back to the video. As you can see here, this way I have split various components. So in the case of Linux, you have this net device data structure which holds the interface or port information. If you do if config or something, you get eth0, local loopback LO or local host LO, and then other ports. So in the case of FreeBSD, it maintains in this data structure which is in sysnet ip_var.h, and if you parse through the source, you can see here you get source in that sysnet and ip_var.h. So you can find the data structure here. So you can see here you have this ifnet, and you can see here this is the interface name it maintains, and it has all this other components. It has also this interface index, just like you get it in net device data structure in Linux kernel source. And if you are aware, I have done an elaborate video series on net device data structure. So if you are interested, you can watch the same in the context of Linux networking subsystem. You can see here. So similarly, I have done also for skbuf data structure. The reason I am discussing is, if you again go back and refer this picture, you have this components which are discussed. So in case if you are eager, if you are still new to kernel programming, you can just watch those episodes. So that's about it. So going on further, if you see in the case of packet, you have this packet data structure which is netcore skbuf.c, and you have the mbuf data structure which is in sys. Under that sys, there is another sys folder. You get it in that folder mbuf.h in the case of FreeBSD. So this is the context for packet, and just before going to the same, we can just go to the source. In the case of Linux, you have this include linux netdevice.h. So if you go here, include Linux, so in this you can find netdevice.h. So we search and we get here, as you can see here. So you have this struct net device. I don't want to much discuss because I have shot an exclusive video series about the same, so I don't want to much discuss. I just want to just highlight the same so that let us see where is that struct net device data structure. Yeah, it is line number 1643 of this version of Linux. So you can see here you have all this documentation of various variables, and then you can go down and then you can see some of its variables. You can see here name, and you have this interface ID and other stuff, interface index and other stuff. So similarly you can find the same in the case of FreeBSD. You have this ifnet. So anytime you deal with TCP IP stack, ipv4 or ipv6, you can find some of the APIs binding both mbuf and as well as ifnet, because it should have that sort of connectivity between these two entities. As such, you have the packet in mbuf which is getting created or which is getting parsed or something happening in the ipv4 stack, and then it should also have a reference to which particular port it is supposed to be sent, or it is received from which particular port and its corresponding IP address and other stuff. So I don't want to go in depth, but as a whole you can get this idea. You can see here it has this MTU and various other stuff which anything relates to an interface. Similarly, you can find in the case of Linux world, you can find its MTU, you can find its MTU and other stuff over here, and also its hardware address or the MAC ID and other stuff. So this constitutes our interface or port. And when we hop on to skbuf data structure, I think almost like 19 to 20 episodes or 18 episodes I have done with respect to skbuf data structure. So very much in depth I have covered. So this is the reason I don't want to much discuss in this episode, and moreover this is not a channel about Linux, this is a channel about FreeBSD. So let me discuss more about the FreeBSD's mbuf data structure modules and its header files, and as well as its implementation in .c files. So if you go here, you have this skbuf data structure. Let me just keep it open so that we can refer the same. Skbuf, it is also in the Linux folder, include Linux. Yeah, you can see here skbuf.h. I don't want to discuss, I just want to keep this open so that we can. Yeah, you can see here it has this documentation before this struct source code. You have various other stuff, and you can see here it has this binding skbuf data structure. Inside you have this device pointer or instance of net device data structure. So this is the device of that corresponding packet in the Linux kernel source. So same way, if you hop on to FreeBSD, you have the source of mbuf in sys folder. You have user src sys, and you have this source in sys folder sys, and in that you can find the mbuf. Yeah, you can see here there is a small difference in the context of skbuf versus FreeBSD. It has some kind of double header or double struct architecture. You have a struct within that another struct which mainly contains some of the important variables or components. So this is the reason, if you see here mbuf, it has this same linked list sort of components. You can find it here next and all that pointers, and then below that if you scroll down you can see here it has something called as packet header, and this is a struct within the struct, and this packet header also is a part of this particular file mbuf.h. So if you scroll a little bit up, you can find the packet header, and you can find various other variables corresponding to the same. And if you find the picture, that is what I have depicted here, you can find mbuf.h, and if you see struct mbuf, you have this struct packet header, and the packet header as the binding with respect to the port information. And in the case of skbuf, you can find it directly. Skbuf device is the binding or the connectivity between skbuf data structure and the port information, whereas in the case of FreeBSD you can find ifnet. So you go here, you can see somewhere it will be binding to ifnet. You can see here struct ifnet, and you have this receive interface or RCV interface. I believe RCV stands for receive interface, whichever port it is receiving, and it is binding that particular port information. So this is what it is getting associated. So that's what I have depicted, so that it is very easy to understand, and you have various APIs for this mbuf. If you scroll down, you have various prototype of APIs. You can see here you have various APIs, and if you need the source of these APIs, you can find it in sys under the sys there is another sys folder, and under that there is a kernel folder kern, and under that there are files like kern_mbuf.c, and there is also another one which is uipc mbuf.c and uipc mbuf2.c. So you can find some of the implementation of these APIs over there, and some it will be just available over here as well. So you can find the same in the case of skbuf data structure in Linux kernel source. You will find it in let me open a new window in net core. You can find it in skbuf.c. So this is where some of the large variables APIs have been implemented over here in this file .c file. So that's what I have just depicted, netcore skbuf.c. So if you want the data structure struct skbuf source code implementation of various APIs, you can find it over there as such. Whereas in the case of FreeBSD, you can find over here. So this is what it is. The reason I'm again doing is there are many viewers who watch this are not starting from FreeBSD. They are started somewhere down the lane their career with Linux, and then now they are hopping on to FreeBSD. Maybe they have a new project in their office, or they are just learning out of curiosity, or they are doing some experiments or research in the case of learning FreeBSD architecture. So this is what it is. So I felt than just discussing some architecture about FreeBSD's networking subsystem, I do in this way so that it gives a nice transition between both the worlds. And in case if you are very new to everything, you can also start with this approach, so that you have this side Linux, you have this side FreeBSD, and then you can start learning about the networking subsystem components and the architecture and the various APIs and modules involved. So that's what it is. So finally, if you hop on to ipv6 and ipv6 stack, you can find in the case of Linux world, you have this ipv6 and ipv4 stack implemented in a net folder. So if you go to this path, you have this net, and you have this ipv4 and ipv6, and in this you find various other supporting files, and then you can find various modules within the same. So the most important modules are input, output, and forward modules of IP stack, which is ipv4 stack or TCP IP stack. So as you can see, you can find the source code over in net ipv4 folder of these modules. So the same thing I have depicted over here, and the same way ipv6 stack has this output and input inside the ipv6 folder. You can see here, you can hop on to v6, you have this, and you can find its various modules for ipv6 stack of TCP, ipv6 stack of Linux kernel source. So same way, if you compare that with the FreeBSD, you have this components implemented in the folder netinet and netinet6, which is inside the sys folder. You can see there, and you have various .c files which corresponds to these components, which is IP output and IP input, and then IP forward. In the case of FreeBSD, I found something matching with respect to the same, which does forwarding is this IP underscore fast forward. Whereas in the case of v6 stack, you have this netinet6. Inside the folder, you can find IP6 output, IP6 input, and then IP6, fast forward or forward.c. I think I have done a small mistake. I need to check, because when I'm going through the source, I found, let me go here, sys net6. It should be forward, not fast forward. I'm going to change the same in my Google Drawing and export an updated one. So you can find the same I have just updated, and what I might do is I'm going to remove this picture and I'm going to again export the picture over here so that it has this particular change, because I'm very sure that it doesn't have that fast forward.c. I think I have done a mistake while doing a copy paste between this and this. So anyway, if you go back here, you can find inet inside the sys folder. As you can see here, inside you have this various modules, IP, it's not options, IP output. Let me close this, and then IP input and things like that. So if you go here and notice the APIs, you can find APIs like you have in this case like mbuf, only it is taking one parameter, and if you go down further, you can find APIs which takes also that ifnet, something like that. So let us just search ifnet, and then we see how it has been how it is getting linked between both. Let us see over here. Yeah, you can see here in this case it is taking these two things as an argument, and if you further go inside, you can find also like let me just ifnet ifp, and you can find it is getting traversed mbuf. You should find something like rcv. It is mbuf. Yeah, you can see here the way it is getting traversed. You have this m, which is meant for mbuf data structure. Okay, you can see here mbuf is m data structure, so m, and it is pointing to this packet header, and it is pointing towards this receive interface within the packet header. So this is what we just discussed in the struct packet header, which is a part of mbuf data structure. So that's what it is. So that's what you can find over here. I don't want to go in depth in any of these tags, because this is again a quick overview. Sometime down the lane I may discuss one day dedicated sys netinet or ipv4 stack of FreeBSD, and that particular episode I'm going to cover its flow of various APIs which is inside IP output, IP input, and stuff like that. And also we can just parallelly compare with the Linux networking subsystem, because it is quite easy to compare with something like that. So with this I would like to conclude the same. Hope you guys loved watching this video. In case if you guys want to reach me, send an email, we be in touch. Thank you once again for watching this video. Have a nice day. Bye bye.